All right, so the last one here, limiting reactant or reagent. I keep calling it reagent out of doing it for years that way. But anyway, limiting reactant or reagent. So the key way I like to do this is with Oreos. And everyone is familiar with Oreos, and that Oreos will have an equation of there's 2 wafers and ballpark 3 grams of cream. You put all that together and you get 1 Oreo. So if you don't have cream, you can't make an Oreo. And if you don't have wafers, you can't make an Oreo. People understand that. But the question becomes, well, if you have a bunch of wafers and a bunch of cream, how many Oreos can you get? And one of those things would be a limiting reactant. One of the starting materials will be a limiting reactant. And the way you determine that is you figure out how much product each one will make. So, and this is a nice how to make a Oreo thing. All right, so 2 wafers and 3 grams of cream make 1 Oreo. That's your balanced equation. So if we have 20 wafers and 27 grams of cream, how many Oreos can we make? So we start with the 20 wafers. Let's go with that in Oreo color. So we have 20 wafers, and we want to know how many Oreos that makes. And 20 wafers, you know there are 2 wafers for every 1 Oreo. So you multiply the tops, divide by the bottoms, and you understand that that makes 10 Oreos. So 20 wafers will give you 10 Oreos. Well, what about the 27 grams of cream? 27 grams of cream, it seems like more, right? 27 is a bigger number than 20. However, since it takes 3 grams of cream from your balanced equation, 3 grams of cream for every 1 Oreo, it turns out that when you multiply 27 times 1 and divide by 3, you get 9 Oreos. So in fact, if you had these starting materials of 20 wafers and 27 grams of cream, you would only be able to make the lowest number, or 9 Oreos. You can't make 10 Oreos. You'll just have 2 wafers without cream, and that is not an Oreo. That's something else. So that is how limiting reagent works for limiting reactant. You will take your starting materials and you will figure out how much product they make. And if whichever one makes the least amount of product would be the one that you're limited by. And that's called the limiting reactant. It's the one that's determining how much you make. So then we got into percent yield in this wonderful video. This guy who puts his money in the machine and he doesn't get out his vending machine food, and he gets very upset. And he gets so upset because his percent yield was bad. And percent yield, remember, is expected, is what you expect over what you get. So you get your received, I before E except after C. I think that's right. So your received divided by expected times 100%. So if he received 0 and he expected 1, his percent yield was 0%. And then it went through a few things where he got up to 50 and then up to 100 thanks to a nice standard by. So here we go. When we do this in chemistry, the vending machine is kind of the reaction, and what we put into it is what we put into it. So instead of money, we're going to put in grams of material, grams of starting material. So we're going to put 25 grams of PbNO3 lead 2 nitrate into this reaction. So we put 25 grams of this in, and we're expecting lead chloride out. We're expecting this stuff out, lead 2 chloride. And we're expecting a certain amount. And we determine what expected amount we want by the balanced equation and doing stoichiometry. So let's start with our 25 grams of PbNO3. PbNO3 2. All right. And excess, and we got lead 2 chloride. So we want to figure out how many grams of lead 2 chloride we expect, because we know what we got. This is what we got. This is what our reaction got. And we're wondering, what do we expect? So to go from grams, can we go from grams of lead nitrate to grams of lead chloride? No, we got to go first from grams of lead nitrate to moles of lead nitrate. And we get that relationship from the periodic table. Grams to moles comes from the periodic table. And anything that comes from the periodic table is going to be 1. And I did the work here already. So you add 1 lead, 2 nitrogens, and 2 times 3. So 2 times 3, 6 oxygens. And you get 331.2 grams in 1 mole of lead nitrate. Now we got to go from moles of lead nitrate to moles of lead chloride. And to do that, we get mole to mole from the balance equation. So lead chloride and lead nitrate, turns out they have a 1-to-1 relationship in this case. So that's good. That came from the balanced equation. And finally, we now need to go, and I didn't leave near enough room, but you've seen enough of these to expect as much. We want to go moles of PbCl2 to grams of PbCl2. So this time we're going to go to the periodic table. Lead plus 2 chlorines equals 278 grams. So the 278 goes on top, and the 1 mole goes on the bottom. So we multiply the tops and divide by the bottoms. And I'm pretty sure I didn't do that. So if you'll forgive me a minute here, I will do it very quickly on my calculator. 0.1 divided by 331.2 and divided by 1s. So our answer is 20.99. So our expected is 20.99 grams PbCl2. Oops, of course that happens. So if we have expected, our amount expected is 21 grams basically, and what we got is 15.7. You divide 15.7 by 21. Oops. 15.7 divided by 21 times 100. And this was a 75% yield reaction. And that is percent yield. And that is the unit. So awesome work, kids. I'm happy. We will have a test on this Thursday. And hopefully